Advanced automation functions. A automated system should not only follow the program of instructions and perform the process as per the instructions. The system should have some additional capabilities, and these are all combinedly called as advanced automation functions. Most of the times these functions are built into the system for a variety of reasons. The first function is the safety monitoring. So even though we say that automated system should function without human intervention, it may not be always possible to completely eliminate the human being. So whenever a human being is there and he is interacting with the automated machine, it has to be ensured that the human operator is safe during the operation and the machine itself is operating in a safe manner. So how the operator is going to be affected? For example, we are having a particular automated system wherein 2 or 3 automated machines or CNC machines which are performing some cutting operation, and you are having a robot which is moving the component from one machine to other machine, and a human being will be regularly performing the inspection activity. Now when the robot is moving, it has to always ensure that it should not make any contact with the human being, otherwise the human being may be injured. Apart from that, while the machine is in operation, if the human being comes very close to the machine, then also there may be a problem to the human being or to the process itself. That example we can apply for in case of the forging, where you are having a very high temperature component on which a lot of force is being applied. So human being preferably should not be there close to the workpiece. So by using some kind of sensors or some kind of devices, it is possible to detect the presence of a human being. If there is any unwanted presence, then the process should either stop or it should give a signal or alarm telling that the human being should either move out or the process should stop. Now with respect to the machine, so whatever the program is given, the operator may not be knowing the actual things that are happening. So even though if the program is giving certain instructions, if the machine is under unsafe conditions, then we'll say that there is a safety issue, either the machine should stop. Now this can happen when you are having a very hard workpiece, the hardness is more than the expectation, it has been loaded into the machine and the cutting process is starting. So there is tremendously high amount of forces that are generated. So if you are having some kind of sensors which are detecting the forces generated or the torque that is being generated in the spindle, if it is exceeding a particular value, then maybe an alarm can be indicated. Or you can have some kind of sensors which are detecting the temperature of the workpiece. So if the temperature exceeds a particular value, we can say that the cutting action is not happening as per the requirement. Or you can measure the sensors which will measure the current that is flowing into the motor. If too much of a current is flowing, then also we can ensure that the process is not happening as per the expectation. So some kind of measurements can be done to ensure that the entire system is operating within the safe levels. Or we can have some limit switches to ensure that the carriageways or the table is not moving beyond the upper limit of that particular machine. So when the table reaches the upper limit, even though the program of instructions will tell that more movement is needed, the machine will not allow it. So some of these issues can happen because of the oversight or because of some other reason. So sometimes the safety will ensure that the workpiece is not damaged, the machine is not damaged, and the operator is also not damaged. So overall the entire operations will be happen in a much smoother fashion without the need to worry too much. So safety monitoring, you can also have some fire safety. You can detect whether a fire has taken place or unnecessary smoke is there. Then also you can ensure that the smoke is put out or some alarm signals are generated. so that the operator is in the safe environment. So that is also a safety monitoring application. The next one is the maintenance and repair diagnostics. So whenever we have automated systems, we know that it involves significant investment. So we want the machine to operate continuously without any wastage of time. So we want to ensure that the machine is not having any kind of breakdown. So that is where the maintenance and repair diagnostics are going to help in ensuring that the machine is always in the working condition and to reduce the downtime that will happen. No machine can exist without having any breakdowns. They will happen, but with maintenance and repair diagnostics, the breakdown time will be very less, or maybe near close to zero during the scheduled. So what are the various features that are present in the maintenance and repair diagnostics? The first one is the status monitoring. So you will be having a lot of sensors which are continuously grabbing or which are continuously collecting the information about the machine. You may having devices which are continuously reading the current flowing through various motors or drive systems, or maybe recording the temperature of various elements, maybe temperature of the coolant, maybe temperature of the workpiece, or you may be having the vibration detectors, you may be having force detectors, velocity measurement sensors. So you can have variety of sensors which are continuously measuring the various parameters of the automated system, and you are having the data collected. So in the case of the status monitoring, with all this data, it may be possible to predict if incoming failure. Maybe you are continuously detecting a lot of vibrations in the spindle motor. So based on the experience, it is possible to know that maybe the bearings are worn out. So maybe time has to be allocated for replacement of the bearings. So maybe you will inform the planning people to ensure that the machine is left out of production for 2 hours or 3 hours. You are replacing the bearing and the machine will be back to operation. So it will not happen that you are machining a component and the bearings have failed. The component is going to be damaged. So that is the advantage of status monitoring. You will know what exactly is happening inside the machine and whether there are any signals indicating the future failure that can happen. Next one is the failure diagnostics. So failure diagnostics means determining the reason for the failure. So you can write a lot of programs to ensure what exactly has failed. Maybe a motor has stopped, motor has burnt out, or maybe some switch has tripped because of excessive current that is being drawn. So the failure diagnostics will tell where exactly the failure has happened, because of which the entire machine has stopped. If the failure diagnostics is not there, this module is not there, or this option is not there in the automated machine, then the maintenance person, whenever he comes to the machine to repair it, then he has to make a lot of questions to the operator. What exactly has happened? Why before doing what operation or what process the machine has stopped? Since it is an automated system, the operator may not be always present near the machine. So a lot of time is wasted in identifying the root problem for the failure. But if you are having the failure diagnostics function in the automated system, you are already monitoring the status. So based on this, the system itself will tell what exactly the problem has happened, and you can correct that particular problem and you can put the machine back into operation. This function is utilized only when the failure has happened. Next one is the recommendation of repair procedure. So if you are having a failure diagnostics, it will tell where exactly the problem is there. Recommendation of repair procedure, this function will tell that what exactly has to be repaired. So it requires more data regarding the system. It may tell that the time has come for replacement of the motor. So recommendation for repair procedure will tell what are the items to be repaired. Maybe for example, the entire machine has stopped because the spindle motor has drawn too much of current. It will say that the spindle motor has stopped then the repair procedure may be to simply switch on the MCB trip and everything will be functioning back online. That is the recommendation for repair procedure. Or it may tell that the motor has completely burnt out, you may have to replace the motor. So that is also a recommendation for repair procedure. Now recommendations are only recommendations. The maintenance operator has to apply his mind to ensure that he is not blindly following. Sometimes the MCB switch has been tripped, but the moment you switch it back on, again it is tripping, and the solution is not continuously resetting the MCB switch. There is some deeper problem which has to be analyzed and appropriate action has to be taken. Maybe the program itself is wrong, so it involves a lot of efforts. But this function will ensure that if a breakdown happens, the system can be put back into working condition in the lowest possible time. That is the maintenance and repair diagnostic function. So error detection and recovery is another advanced automation functions which are built into the system to ensure that the downtime is minimized or the system is not going to function in an unpredictable manner. So whenever the system functions in unpredictable manner, we can call it as an error, or the output of the system is not as per the instructions given, then also we can call it as an error. So there are two aspects here. First we have to detect the error. Next, once the error is detected, how the system is going to respond to that particular error. That is the error recovery. So if we want to detect the error, first we have to understand what are the different types of errors. The first one is a random error. So these errors will happen because no process will be happening exactly as per the requirement. There is always a certain amount of tolerances to various processes or parameters or the outputs we are able to achieve. So something will fall in the extreme beyond the requirement, then that will be an error. That is the random error. Now next one is a systematic error. These will be due to some aspects of the machine itself or the machine features. These are the systematic errors, and these can be detected very easily, and you can have certain actions to them so that the system is functioning as per the requirement. The third one is the aberrations. Now these are highly unpredictable events that can happen which cannot be predicted and which should be considered as the part of the system itself. To some extent, aberrations can be eliminated by having a proper calibration and maintenance activities, but aberrations are always going to happen. So random errors, we can have some statistical tools to detect whether the error rate is very high. If the error rate is very high, then some deeper analysis is needed to find out the source of this particular error. Thereby we can reduce the occurrence of these random errors. Sometimes they may not be purely random. It may be because of some reason or some feature of the machine. Systematic errors, they can be more easily referenced to a particular aspect of the machine and solving that particular issue. The systematic errors can be eliminated to a large extent. So what are the problems in error detection? So the main problem in error detection is to make a reasonable guesses of what are the errors that can happen. So only if we know what are the errors that can happen, we can have certain provisions to know whether it has happened or not. So detection can be done by using some sensor. So you should have some sensor which should be functioning, and you should be capturing the appropriate data, and you should be able to set the limits so that when we consider the particular parameter as an error and when we say that it is within the tolerance limits. So it may not be possible to put a sensor for each and every aspect. So that is one of the problems. Since it is not possible to capture all the data, it is not possible to anticipate all the errors that can happen. So it may not be possible to detect all the possible errors that will be present in the system. So whatever the errors we are seeing, it is always preferred that they are properly categorized, analyzed, and appropriate actions are designed to ensure that these are eliminated to a large extent. So the next one is the error recovery. Error recovery is more concerned with applying the necessary actions to overcome the error and bring the system back to the normal condition. So there are 4 main strategies that we can implement. First one is, once the error is detected, then the first strategy is to make adjustments at the end of the current cycle. So whatever program of instructions are given, once the programs are executed up to the end, before the beginning of the next cycle, the adjustments will be made. The second type of error recovery is the adjustments will be made during the cycle itself. We are not going to wait till the end of that particular cycle. During the cycle itself, adjustments will be made. So the next one will be the process will be stopped, the corrective action will be invoked, and then the process will be restarted. And the last one is stop the process and you have to call for help. Now this is the increasing order in the seriousness of the error. So the first case, the error is very minor. We can allow it to exist without much of a problem. Maybe at the end of that particular cycle we have to attend to that particular errors. So in the second case, it is slightly serious problem. In the same cycle itself we have to implement the corrective action. So the third and fourth are even more serious issues. So what are the various errors that can happen in the automated machining station if you are taking? So you can have a loss of power. What will be the error recovery system for this one? So once the power is lost, the program of instructions have to wait. When the power has again received, whatever the program has stopped, from there itself the program has to restart, which means usually when the power is switched off, the tool will be moved away from the workpiece. When the power has come back, again the movement has to happen. So this kind of error recovery has to be implemented into the system. So whenever power is going off, the tool will not start away from the same position. First it is to go back and then it will coming back into the nearer to the workpiece, and then the machining process will be continued. Now if you are having a tool breakage, so what is the recovery? So once the tool is broken, we have to definitely stop the process because we cannot allow the machining to happen. Maybe you have to call for the help so that the tool will be replaced. The tool will be verified why exactly the breakage has happened, and then the tool will be replaced. Maybe you are finding the dimension of the component is coming slightly excess, but it is within the tolerance. You will allow the program to execute. At the end of that particular process, you will do some kind of an adjustment. Maybe the tool is not properly set, or maybe the tool has worn out, because of which the dimension is increasing. So you may make adjustments to the program itself, or you may make some changes in the settings of the machine, and then you are going to execute. So then more serious an error, the process has to be stopped. If the error is less serious, we will allow the system to function as it is. At the end of the instructions, we are going to implement the corrective action. So error recovery is a very important aspect. It is required to ensure that the components are manufactured or processed accurately. Otherwise, the errors are going to exist and the variations in the component will be very large, or the components themselves may be damaged. So error detection and error recovery are some important functions of a automated station.